Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Trine. This is their part number EN400CMRP. This is what Trine would call their go-anywhere strike, I think is how they put it. This is a electric strike that is more of a kit, actually. When you order this, you're going to get a number of components. You're going to get different components that will allow you to, I think, hit pretty much every application that you might ever need. Excluding deadbolts, which are pretty uncommon when it comes to electric strikes. So let's talk about exactly what this is. Let's first take a couple of basic dimensional properties. This is going to be a 4 7/8 strike, so the overall height of the face is 4 7/8. The overall width, typically 1.25 inches. That's going to fit into a standard ASA prep, provided you then cut the face back of the frame. The 1 5/8 or so that's required, and we're going to take a look at the frame prep for this strike. The document, I should say, in about 3 7/16 or so height. Now, what is included with this, and where would you use it? Let's talk about that now. So the first question is, what is included? Well, you're obviously going to get a strike. It has a couple of wires hanging out here, so there's a coil inside of here. Okay, this is going to come from the factory fitted with these two wires, which we'll look at in the instructions. Tells us that it's the 12-volt coil that's inside of here. And it has the standard keeper that's here. That's already installed. A couple of screws back there will be for the shims that I'll show you in a bit. What else is included with this? You're going to get a 24-volt coil, and you're going to get a rim exit or a Pullman latch keeper with this as well, along with those shims that I just mentioned, and a couple of wire connectors, or electrical wire, not wire nuts, but there are a couple of dolphin style connectors. So we've got the strike. You're going to get the rim keeper that's going to come with this. And here it is. You'll replace the keeper inside of your electric strike if you're using a rim exit device. So you'll get this. You are also going to get the 24-volt coil, and we know it's 24 volt because it's defined for us in the installation instructions. Okay, you may or may not need to replace it. In my experience, if I was going to package this from the factory with a voltage, I would probably pack it with a 24 volt. Obviously, Trine's experience tells them that 12 volt must be more common for their client base, and 12 volt is going to be seen more commonly in alarm and intercom systems, is where that's going to be seen. You're going to get those two, and I believe the proper term is indeed dolphin connectors. That'll be to connect your wires together. Then there's also going to be shims that I had just mentioned. Forgive me, a couple of 12-24 flat undercut head machine screws for attaching that to a steel frame. These shims, they're meant to go inside of the keeper, and they're just going to obviously screw here, attach with small screws that are included. And there's 3 of them, so that you can build out, you can make smaller the width of the keeper area. Okay, you might have a situation where the latch bolt's just simply too loose inside of there, and you want to effectively close that down to keep that tight. So that's nice that these 3 are included. I don't know the thickness, but my guess is about 60 thousandths. Let's take a look. About 75 thousandths. Yeah, about 75 thousandths is how thick each of those shims are. The screws appear to be long enough. Well, I would think they'd be long enough to get all 3 stacked in there. Otherwise, why would they supply 3? Yeah, let's take a look and see what they have included here for screws. Yeah, well, we'll take a look. Yeah, it appears to me as if what they're doing here is supplying different length screws depending on how many of these shims you're going to use. But we'll look at the installation instructions and see what is supposed to be supplied. So the 3 shims. Now, this funny thing, this roll pin, let me tell you this. Don't throw this away until you are done with the job. Without this roll pin, you will find it almost impossible to rehand this strike, or to rehand it, to change the function from fail secure to fail safe, and vice versa. To change the coil, I don't think it's a problem to change the coil, but you're going to find it really, really tough if you have to rehand that. And and I've covered the rehanding of this exact strike in other videos, so I'm not going to do it here. There is a bar that's holding this all together. In order to hold the spring back when you've got the keeper in there, you basically need to have a roll pin holding the new keeper in place as you push in the permanent pin. And without this, the spring always flaps or folds over on itself. I've tried to do it without this. Man, as soon as you have this, it'll make the job go really easy. I'm not going to rehand this. I'm not going to reverse it. It is covered in other videos, at least 2, I think. So we're going to go over what the EN400CMRP is. Now, there's a final thing that's included. That's a weldable gate box. You're going to get this as well when you order this. So in summary, you're going to get the box that you need to attach it to a structure should you need that. You're going to get 12 or 24 volt capability. The instructions say AC or DC. You're going to get the ability to do this as left hand or right hand. You're going to be able to get the ability to do this as fail safe or fail secure. You've got some shims. You've got the tools and parts necessary to get it installed. The only thing you have to do is provide a switch and a power supply or incoming voltage. So a really great strike. And when they say go anywhere strike, it's probably going to work in all of your applications. The depth of that keeper, that's pretty important. It goes in pretty far. That's important because when it comes to the world of electric strikes, and I learned it the hard way myself. Sorry about that. I learned it the hard way myself that you must have the proper electric strike based on the application. If you've got a mortise lock with a 3/4 inch latch projection, you have to have a keeper that's deep enough to accept that. If you use an electric strike that's meant to accommodate, say, a 5/8 projection or 1/2 inch, it'll work, but very intermittently. It is definitely not intended. If you have a lock with a particular latch that is not meant to be compatible with this, you have to pause. You've got to select the strike for the application. But what I'm driving at, this strike right out of the box will handle cylindrical locks. It will handle mortise locks. It will handle rim exit device strikes. This would technically handle a surface vertical rod, less bottom rod application as well. I would think that it would. It being a Pullman latch, it's not going to handle a bolt. Would it? Could it work? It might, but it's not meant for that at all. But we'll see in a moment here the installation instructions, and we'll determine if I have called out anything incorrectly. Now, before we switch to the screen view, in order to get this to operate, the wires always must be pointed towards the top of the unit. You may need to rehand this. You might need to move the coil over depending on the hand of it. And you'll note for, let's just say, a right hand application, or it's easier this way, for a right hand reverse. This is locked. Okay, but if I had a, this would be left hand reverse. If I had a right hand reverse, now I'm unlocked. So depending on the hand, you might need to reverse this, and depending on the function, fail safe or fail secure, the handing and the function, fail safe, fail secure, are not the same thing. You might need to move the coil to the top if you've got the other handing, and you might need to flip the slider over, depending on whether you want it always locked in the absence of power, which is fail secure, or always unlocked in the absence of power, which is fail safe. So when the power is cut, you want it locked or unlocked. No power. Power is off. Do you want it locked or unlocked? If it's locked, it's fail secure. If it's unlocked, it's fail safe. You'll have to know that. And yeah, are you going to likely have to remove the cover and get inside of here? Absolutely. There's a strong chance you will. However, you can also specify the function and the hand at the time of order, and we'll relay that to the manufacturer and ask if they simply do it there before they ship. We'd sure like to think that they will. Trine certainly would. It might be a matter of them shipping something that's in inventory on the shelf ready to go. So by all means, define what you'd like. Left hand, right hand, reverse, right hand, reverse. Fail safe, fail secure. That sort of, and then the voltage, 12 or 24 volt. So let's switch down to the screen view and let's take a closer look at all the supporting information. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. All right, let's dive into this strike. So what we're going to end up doing is listing it in the website in all of its derivatives, and the derivatives are going to look like this. So, electric strike, EN400CMRP, volt. And the variables are voltage, latchkeeper, function, and hand. Your voltages are obvious. Your latchkeeper, either it's for a latch or a rim panic device. Your function, FSE or FS. Fail sale. I realized I had a spelling error. So voltage, the type of keeper, fail safe or fail secure. FSE is fail secure, FS is fail safe. And then your hand. So I'm just going to say now that I can't guarantee that they're going to ship it out correctly, and you are likely going to have to refit the unit in the field because the manufacturer does not list the hardware in this sort of orientation. They're selling it as the go anywhere strike, which is the you got everything you need to make almost everything work. So you're probably going to have to rehand or change the voltage. It would be unusual if you didn't. But nonetheless, you'll be able to at least select the exact orientation or derivative product that you want, and hopefully that is the way that it's shipped to you. Okay, so let's get back to what we were working on. And here is our strike. And this is the cut sheet that we're looking at, the one box solution, the only electric strike solution on the market that can handle cylindrical locks, mortise dead latches, and rim panic devices. So what we're basically talking about is the design of the latch bolt for those three applications, and we're really looking at something like this. You've got a latch and you'll have your deadlocking tab back here, right? Okay, and that spring loaded that goes in. That's a regular latch bolt. This, the projection from the face, is what's important. How far out it projects. Half inch is typical. You might see something that's 5/8. Mortise locks are usually going to be 3/4. The point is this latch bolt, this electric strike will handle up to 3/4, which is going to be cylindrical and mortise locks. But you could also have a typical Pullman latch on your exit device. So it'll handle a latch bolt shaped more like a Pullman latch as well. So that's what they're driving at by giving you that data. The EN400 12 DC 32D complete in the box. So it's coming to you at 12 volts. That's exactly what that is indeed saying there. The RP latch, which is the rim panic, is change in the field. The voltage is change in the field. The gate box is included. field reversible for fail safe or fail secure. So they're telling you they're not going to change this, but at least you'll be able to specify it the way that you want when you're ordering it. Gate boxes included, available only in 630 finish or what's called 32D. Now in our website, we'll be able to get to the, let's just pull it up right now. So when we search for the EN400CMRP, below this video is a link to the manufacturer's page. Let's copy that. By the time you're seeing this video, this will likely be completely formed in, links, everything added. But from that link, you'll be able to get to the Trine website and put in their search box the part number. And then you have to scroll down. They're using a free search situation. EN400CMRP. Well, here are the important documents. Catalog page. We just went over that. That's the cut sheet. Dimensions. That's nice. We went over that initially. That document is there as well. I'll leave that to you to decide what you need to do. The RP dimensions. This is when the rim panic keeper is installed. The gate box dimensions. That's here. If you want to see what that is, you've got all the dimensions. I believe it's 14 gauge cold rolled steel. Frame prep. I mentioned this earlier. You're going to need to prep the frame for this. I don't see why this would not work in an aluminum storefront, with the exception of the fact that you need quite a lot of face dimension there. Aluminum frames generally aren't that wide. So this is probably not going to be the best choice for an aluminum storefront application. You want to test that first. Check that out. Okay, now, what's not here are the installation instructions, but I have those printed out, and here they are. It's a gnarly document. It comes with the, obviously it comes with the strike. So we're gonna try to decode this. So this is what would be page 1. We're just going to look at page 1 here. The way they have this laid out is you're seeing page 1, page 2, page 3, page 4. Well, you can see it down in the bottom area. 1, 2, 1, 2, 3, 4. Okay, so let's look at page 1. They give you a list of everything that's included. EN400 latch and the RP latch. The slider is already installed, and they define those parts down here. 3 is the slider. In fact, that's how you govern fail-safe or fail-secure with that slider. You've got 2 coil assemblies, which are part number 4. You have the screws for the cover. There are 2 of those. I see one here. I don't immediately see where the other one is, but that's definitely in the box. You've got the frame cover, part 6. What they're showing us here is a detailed parts drawing of everything that's included. The 2 latches, the spring, the shims should you need them, your assembly pin. That's the roll pin that's included. Then your latch pivot pin. You need both of those to render a change. On page 1, it's important to note that UL listing is void when using fail-safe action or RP latch for rim panic devices. So if you set this up to be fail-safe, you no longer have a fire-rated strike, because the strike's still fire-rated, but you've put it into an orientation or a derivative operation that is in violation of it being fail-secure, which it must be. But they're also saying if you put the RP latch keeper in there for a panic device, it's no longer UL listed. Which tells me they just simply didn't test it for that application. Or they did and it failed. So it is UL listed. It's UL 294 listed as well. I believe that's an electrical code reference. Burglar reference resistance UL 1034. ANSI standard, and it's grade 1. That means it's 1,000,000 cycles. I'm not familiar with New York City building code, but that's obviously a listing for something important. Down here, with AC voltage, you'll hear a buzz. It's giving you not only the voltage, AC or DC, but also how many amps and how many ohms you're dealing with. Now, the ohms you're not going to really encounter because the ohms are just the resistance. And what's funny is the way they've laid it out is E equals I times R. Voltage equals current times resistance. Now, the reason that's really nice to have those values, even though you don't need to know them, what you need to know is 12 or 24, AC or DC, and you need to know how many amps so that you could provide the strike with an adequate quantity of amps in your transformer or, more likely, your power supply. Transformers are AC voltage, power supplies are DC voltage. However, if something doesn't work right on the strike, you could take your multimeter and run resistance through the coil to determine what the ohm reading is. And in fact, I could do that very easily with my multimeter. And you know what? If I don't forget, I'll do it before we wrap up this video to just show you how that's done. The point of measuring the ohms is to tell you whether or not you have a healthy coil. Okay, so that's page 1. Now page 2 is down over here. And this is going to talk at length, page 2. This is going to talk at length about the handing. So I'm kind of zoomed in to where I've got page 2 occupying our screen. Door handing. The latch assembly. Just shows you what that's supposed to look like. Swapping latches, step 5 below is where you'll look at that. So the bottom line is you need to make sure that when the wires are pointed towards the top, the keeper is either locked or unlocked in the absence of power such that it suits your requirement. So if the wires are up and it's unlocked and that's what you want, then you want fail safe. The wires are up and it's locked, then it's fail secure. You just then have to determine whether or not the handing is correct. You might need to reverse that coil to the other side. The point is that the slider is operating on gravity and it's either locking or unlocking. And that's why when the wires are up, because that's how it's working. When it's energized, it will suck the slider up towards it. When it's de-energized, gravity drops that slider back down. The fail-safe or fail-secure is determined on this notch assembly that's here. You're either presenting the notches in this orientation or in the opposite orientation, depending on whether it's fail-secure or fail-safe. That's as important as getting the voltage correct, because it'll either be secured when you want it secured or it will be unsecured when you want it secured. So that will have to be determined. And what they're showing you here is for right-hand assembly, your slider needs to look like this, where the dimple is towards this orientation of the case, or for a left-hand assembly, it's going to be at the bottom. You'll flip it over. Now looking at our left-hand assembly, you know, you need to just observe where that dimple's going to fall. Depending on how you want your fail-secure or fail-safe operation. You know, when you put it all back together, obviously you need to test it to make sure it works right. And if it doesn't, you got to disassemble it and study and figure out why it's not going right. So that's the balance of page 2. And again, I've covered the rehanding of this at length elsewhere, so I'm not going to now. This video will be long enough without me doing that. The position of the electric strike in the door jamb will be the same for a right-handed door and a left-handed door. What they're saying is the latch is in the center line of the body as measured from either end. Now, if you're going to use this with a mortise lock, you have to be mindful that you're not installing the center line of the strike at the center line of the lock body, because that's not where the center line of its latch is, which is indeed the case with a rim exit device, or a cylindrical lock, forgive me. In a similar manner, the position of the electric strike in the door jamb will be the same for a left-hand reverse bevel or a right-handed door. Whether the door swings in or out doesn't matter to the strike. So this could be right-hand reverse or it could be left-hand, what they're showing right here. The EN strike must be installed with the coil assembly up. That goes back to the gravity part I talked about earlier. In this position, the electric strike will be locked without power, fail secure, or locked with power, fail safe. Meaning the way it comes from the factory, this is how it's going to work. It's going to be locked automatically, because when you take it out of the box, you've not connected it to power, it's locked like I'm about to demonstrate. You put power to it, and it's going to unlock. That makes it fail secure. Before performing handing procedure, view strike lip in up position, wires at top, to determine if you even need to do it. It might be the right way when it comes out of the box. So, you know, it goes to say, if you're using this for a rim panic, you know, a rim panic device is going to need this to be arranged correctly. You're not going to install this down into the rabbet of the frame. You'll be installing this on the soffit or the stop of your frame, obviously. I don't know if the templating gives us any guidance for that. We'll see what the paperwork has to show. So next step is to verify the voltage rating of the strike is compatible with what your incoming power is. When you study the color of the wires on the solenoid, pardon me, it's not a solenoid, it's a coil. Our strike is packaged with DC because our 12-volt coil has two white wires with orange stripes. It has the additional coil that they're black wires with what appears to be a white stripe on them. But it's this. We don't have coils in this arrangement. So if you're doing AC, it'll have to be ordered that way. But, as I said earlier, we're going to have all of the part numbers for that purpose. Using templates supplied with the strike, mark door jamb for cutout and screw holes. Yeah, that's the dimensions document that we looked at earlier. There is no separate template for this, but it does go back to this document's in the package. This is what they're talking about. So if you're installing this for a rim exit, it's going to end up going over here. But you've got the dimensions for that sort of application for use with rim exits. But what they've not done is provided you a drawing for a rim panic application. So you're going to need to lay that out, maybe even build a mock-up to be sure that you're getting it installed in the proper location. Note, proper installation, center line of latches must be aligned. So what they mean there is the center line of the latch, regardless of it being cylindrical, mortise, or rim panic, has to be aligned with the center of the strike, or the strike has to be centered on the latch of the locking hardware. That's probably a better way to say it. Prepare door jamb as required for the strike. Leave sufficient space for splicing between power supply wiring and electric strike wiring. They're giving, this is nice, they give you a guide in terms of the gauge of wire based on what voltage you'll be running and how far away you are from the power source. For DC operation, we'll look at the wiring diagram in a moment. DC operation is considered silent. AC will make a buzzing sound, and that's because of the wave. DC power is linear. AC power is a sine wave, and it's this sine wave that gives the buzzing result. If you have DC operation and you want an audible sound, you'll have to add an enunciator. They call it a buzzer. It's nice to be able to hear when you're intended to pull on the door open, and DC doesn't give you that audible sort of... for 12 volt or 24 volt, you'll need the proper enunciator or buzzer, should you want that. Again, when you have an AC strike and someone closes the circuit, you can hear the strike. You can't when it's a DC. You may hear a click, but you won't hear anything but that. Wire your unit, attach it to the mounting tabs that are there, install the strike, verify that it operates correctly when energized. If you are doing a DC strike and you have AC coming in, you'll need a rectifier. Here is your typical, let's see here now. Here's your typical AC installation. Yeah, right here, using DC. It should be called a power supply. And I say that because I can see that there's a rectifier here, which tells me everything over here is AC voltage. This is all DC voltage, but all of this is DC voltage. Here's where your enunciator would be wired, should you have that. Here's your switch. So you've got 4 components in an electrical circuit. This is a good diagram to allow us to understand that. 4 components. You've got power, you've got a switch, you've got a load, and then the conductor. Those are the 4 components that you always must think about when you're working on an electrical circuit. And that's the balance of page 3. Page 4 is the troubleshooting, and I'll leave that to you to go through. Really, if you're going to get into trouble with this and maybe some hair pulling, it's going to be how to rehand it. And don't try to rehand it without the assembly pin. Take it from me, I've tried. I got it to work once and I wasted 2 hours of my life. The first time I did it, I said, my goodness, how do they expect you to do this, to reverse this? And never once wondered what that roll pin was. Until I got so frustrated, I said, well, maybe I should look at the instructions. And within 10 seconds, I realized, hey, dummy, that's what that roll pin is for. So use the roll pin. Don't be like me. Troubleshooting, I'll leave that to you to discover what is the story with that. Below this video is certainly going to be the link to the Trine site where you can pull up not only all of the Trine products we sell by means of this horizontal navigation, but also a link to the manufacturer's website, as well as a link to their full product catalog. We're now going to switch to wiring this strike just to show you some basic operation with a power supply, and then we'll wrap up this video. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Okay, what we're doing here is just testing for voltage. So right now, the power supply is on. It's literally producing output voltage. And we know that there is a 12-volt coil in the electric strike because of the coloring of the wires, according to the installation instructions. We can see that we've got output voltage by that green light that's there. And before we test anything, we have to be sure of what output voltage we're getting, because this is a 12 volt coil that's in there. And according to the installation instructions, because of the white and the orange stripe, we've got 12 volt DC. Well, if we look right in here, it appears as if we're running 24 volt to that coil. So that is not going to work for purposes of what we're doing. Yeah, perfect. I'll get them going. So let's test and see how many volts we're getting. Let's pull the strike out of there. Let's put our voltmeter so that you can see it. Output voltage on this power supply, according to the instructions, are 10 and 5. Oh, pardon me, 5 and 10. You can see that we're getting a negative value. so we just have to switch our leads. Yeah, so it's putting up 27.4 volts. So let's turn off, let's unplug the power supply. Now what we're going to do is get in here. We still have a light in there, so we're going to want to let that sit for a minute. It is definitely unplugged. And that LED appears to be dimming. Yeah, it's dimmed. So it's off. We're going to switch this over to 12 volts. And let's test for voltage again. So we've got it plugged back in. I believe 5 was our negative terminal. Yeah, so it's producing, you know, it's supposed to be plus or minus 10% kind of thing. It's running a little heavy, but it's not going to damage anything. So we now know that we've got proper voltage coming out of here, and you weren't able to see me. That's terminals 5 and 10 is where I'm getting that voltage. So it's plugged in, so let's be mindful of that. Now our strike, when it's in this sort of orientation, wires are up, it's locked. Okay, so I'm going to place this in there. And because it's this coil's not going to matter which lead goes. So you can very likely hear that. I'm going to pause this video so I can actually wire this, and then actually we'll just do it now. I have the power supply disconnected to where I can know that there's no voltage. I'm going to loosen my 5 terminal and my 10 terminal. Plug it back in. Okay. Coil's up. It's unlocked. Wires are up. Sorry. The wires are up. And this is unlocked because power is running to it constantly. When I drop power out, it's going to relock. Okay. We've got the power disconnected. You may have heard that click, and now it's locked again. Okay, and our LED fades, so we're not getting any output voltage. So just this part of the video is just to show powering it and show what its behavior is. Very important step, however, 2 very important things were considered. Obviously, knowing what voltage the hardware requires. These wire colors tell us it's 12 volt. And then knowing here of what we were set to. We were not set to 12 volt initially. I could have simply installed the 24 volt coil, but just no need to. Let's continue. Okay, in conclusion, I'm quite partial when it comes to Trine products. And that is quite simply because I have been using their products for decades. I have never had bad luck or a bad experience with any of their products, so that's good. Otherwise, you do get a bit snake bit, as I had said earlier. And I'll tell you this, I have called Trine a handful of times in my career because I was confused. I didn't know what was to be done. It was not clear. And I'll tell you this. I'll say this about Trine. 100% of the time that I call, someone either answers or I leave a voicemail. 100% of the time, I get a call back. Every single time, I get a call back. 100% of the time I get a call back, I am speaking to someone who's utterly expert when it comes to the understanding of my question and their product line. In fact, so much so that it's, for that person that I'm speaking to, it is extremely quick and easy for them to answer my question and clear my confusion. And I'm really grateful to them for that excellent level of customer service, because while in the industry of electrified hardware, you generally get really good tech support. You generally do. But also, what might be true to say in some turns, you'll also get to speak to people that don't understand the product line, in fact, and may not yet have gained the amount of expertise over the subject matter that Trine has. Their bedside manner is exceptional. Their expert knowledge is beyond above average, and I only wish that I had more opportunities to sell Trine products, meaning to fit them into the project. They're my go-to in lots of instances. I believe that they're comparatively a relatively small company that's independently owned, and they just make a nice quality product, and they make products for the entire spectrum of what you're looking for, meaning if you want the cheapest strike available on planet Earth, they've got something to supply you. If you want something that's grade 1 exterior rated, install it outside, and that's where I use this outside application. They've got it, and they've got everything in between. They've got accessories as well, push buttons, annunciators, as I had said. And you'll want to probably look into their website for a better overview of that material, because I don't know how well we present the entire line, at least at this moment, to give you a quick summary. I would suggest their catalog. Pardon me, I would suggest their website. If you have any questions on the EN400CMRP electric strike, this is the entire gizmo, or any other Trine product, please feel free to reach out to us. And thank you. Thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.